Okay, so going to part 2 of interpreting multiplication graphically. We're going to look at multiplying a complex number by something that isn't on the number line. Now we're going to try and limit the things changing here. So we're going to pick complex numbers to multiply by that have a size, a modulus of 1. And you would expect multiplying by 1 not to change the size of something. So we're going to try and pick values that don't have a modulus of just 1. So if we start by picking I as the thing to multiply by, that clearly has a size of 1, it's just 1 in the opposite, in a lateral direction. We're going to multiply I by Z, so Z is here, Z is 12 plus 5I. So if we do I lots of 12 plus 5I, we get 12I take 5, which rearranges to negative 5 plus 12I. So that is negative 5 plus 12I is there. And that is a Z. All right, so we'll draw our, we'll go to the origin to get some idea of what's happened here. So that was this is the argument of Z, this is the modulus of Z, and AZ, we'd expect to have the same modulus because the thing is multiplied by the size of 1, and that looks about true. A quick bit of Pythagoras convinces you that they've both got a modulus of 13. But it clearly has been the angle's changed. Maybe it's just simple as a rotation, but there's something going on with the angle, that this is no longer in the same direction. Okay? And if we look at some other examples, we might start to get another intuition. So we've got W we're going to multiply by a couple of other complex numbers. Some of you who are quick at trig will spot that these do in fact have a modulus of 1, and they're at nice simple angles from the origin. So if we use a calculator to do the multiplication quickly, we can do 6, get rid of the reflection, 6 take 4I, bracket, a half plus root 3 over 2 I, close bracket, multiply out, we get this third as a decimal, so I can get some chance of plotting it accurately. WB is 6.464, that'll be that accurate, plus 3.196I. So that is 6.46 plus 3.1, so something like that, something there-ish. Okay, so that is WB or BW, and we'll do something similar with CW. Probably plot B, I'll give you a clue where it is, shouldn't I? So shift cosine. So this has a radius of 1 and an argument of pi over 3. And this has a radius of 1 and an argument of 3/4 of pi, maybe? Shift sine negative root 2 divided by 2. Negative a quarter, so sorry, it's 7 quarters? 7 quarters of pi, so there we go, anyway, right. So, WC, bracket, 6 take 4I, close bracket, times, fraction, root 2 over 2, take root 2 over fraction, root 2 over 2, I, close bracket. As a decimal, so we can plot it, we get 1.414 take 7.071. 1.4 take 7 is down here, 7071 is down here somewhere, so it looks like that might be WC. So, we expect these all to have the same radius because this modulus was 1, and we'll just check that out by drawing an arc in. So that looks like it's pretty similar. Yeah, that's pretty good. So those are all on the same circle at the origin. If we look at their radii, look at their arguments, so we're going to compare that to that. So what is this angle? Well, it looks a heck of a lot like pi on 3 to me. And what on earth is that angle? Well, it looks a lot like 7/4 of pi to me. And if we come back to this one, what is that angle? Well, it's pi on 2, which is the same as the argument of I, isn't it? So, it looks like, when multiplying complex numbers, they are rotated by each other's angle. And we can check that by summation. So this total angle here is this one plus this one, right? So which is the argument of z plus the argument of a. The angle of w is, the argument of w, sorry, is this, let's say. The argument of c is pi on 4, negative. These two together add to make that angle. So it looks like the angles simply add together. The arguments add together when you multiply complex numbers. And we'll do one more check in our third part of this to see if that holds true for more fiddly complex numbers.